the superposition principle, we had three kinds. One was interference, other one was stationary waves, which consists of transverse as well as the longitudinal waves. And the third one was B. So see, we have covered this interference. Any doubts from here? Okay. So let's start with stationary waves. I hope the screen is sharing with you.
Yes.
Okay, see what is meant by stationary waves, and these stationary waves are also known as standing waves. So see, when two progressive waves having the same amplitude, when they have the same frequency and are traveling in opposite direction, they're traveling with the same speed along the straight line, but in opposite direction. These waves interfere to produce a wave that is known as the standing wave, or that is known as the stationary waves. For example, if I say this is wave X, this wave X is moving. Now with this similar, just same amplitude, let's say another wave, let's say N. If this is also moving and the frequencies are also same, but they both are moving in opposite direction, like this. But the amplitude is same. If A1 is the amplitude of X wave, and if let's say A2 is the amplitude of this N wave, then A1 would be equal to A2. These waves are known as the standing waves or the stationary waves. But see, in a stationary or standing wave, the amplitude varies from place to place along the wave. This does not mean if it says same amplitude. This means same amplitude is of both the waves, but the amplitude can vary over here. Means if let's say this was 5 centimeter, this was 5 centimeter. So it may happen that this will be 4 centimeter and this will also be 4 centimeter. So see, there are points where amplitude of particles of the medium is 0. Wherever the amplitude of the particle of the medium is 0, we say these points are called nodes. So if you see these points, here the amplitude is 0. So what are these points known as?
Nodes.
Nodes. Then see, contrary to this, midway between these nodes, there are points where the amplitude of the particles of the medium is maximum. Then we say those points are known as antinodes. For example, the highest peak points. These are known as antinodes. So what are nodes?
Where amplitude is 0.
Amplitude is 0. And antinodes?
Where amplitude is maximum.
Where amplitude is maximum. So see, again, stationary wave will be also of two types. Transverse stationary wave will be there and longitudinal stationary wave will be there. So see, regarding transverse stationary wave, the transverse stationary waves are formed due to the superposition of two identical transverse waves which are traveling in opposite direction. Like if I tell you, if I say the stationary waves produced on the vibration of string, then these waves are produced known as the transverse stationary wave. Whereas if the longitudinal stationary waves are formed due to the superposition of two identical longitudinal waves, which are obviously moving in opposite direction, then we say those waves are known as longitudinal stationary waves. Like you can say stationary waves which are produced in organ pipes. We'll be discussing organ pipes. That is included in your syllabus. So those kind of waves that are produced within the longitudinal waves by the interference of two longitudinal waves, then we say these are longitudinal stationary. Now see, there are few characteristics of stationary waves. These stationary waves have few characteristics. The disturbance is confined to a particular region between the starting point and the reflecting point of the wave. And also the disturbance does not move forward or backward. The disturbance is not transferred from one particle to another particle. All right. And then we have nodes, we have antinodes. All the particles except for these nodes will execute SHM where? About their mean position with the same time period. Like if this is the wave, every particle that is present. Let's say these are the particles present. Then all these particles except for these nodes. If you exclude all these nodes, then these will be executing simple harmonic motion. If the particles are in this space, then it will execute SHM. Fine. And also remember that in a stationary wave, the particle at nodes always remain at rest. The particles that are present over here, these always remain at rest. And also twice each vibration, all the particles of the medium pass simultaneously through the mean position. And one more thing, the direction of motion of the particles is reversed after half vibration. You can see the direction gets reversed over here. Then again the direction will get reversed. Then again the direction will get reversed. So these are the few characteristics of stationary waves. Now let's see what is the equation of stationary wave. Stationary wave or standing wave. See, if this is the incident wave, one will be the incident wave, other will be the reflected wave. One wave that will be coming, that is known as the incident wave. So incident wave has its equation. Y incident is A sine omega t minus kx. What is omega?
Angular velocity.
Angular velocity. Okay. Then this wave will get reflected. This will be reflected and we will have a reflected wave. So what will happen? Just the direction is reversed. So for the reflected wave, we will be having omega t plus kx. Okay, one more thing I told you. If this is the equation, yi is equal to a sine omega t minus kx, can anyone tell me if it's moving in positive x direction or negative x axis?
Positive x.
Positive x axis. And this for reflection one?
Negative x.
Negative x axis, right? Because minus sign indicates positive direction. Fine. Okay, then I have told you superposition principle also. That the resultant wave, that the resultant equation is given by addition or algebraic addition of each of the waves. So y total will be what? Y incident plus y reflected. Now see, if I add these two equations, a sine omega t minus kx plus a sine omega t plus kx. So what I'll get? Y is equal to 2a cos kx sine omega t. So this is known as the equation of a standing wave. This is the standardized equation for a standing wave. The previous equation, this was for a general case, for a wave that is incident. This is for the reflected one. If you are specified that the wave is a standing wave, if it is a stationary wave, then you will be using this. Y is equal to 2a cos kx sine omega t. So this is the equation of a standing wave. Now see amplitude. The way I have told you, if this is the standard equation, y is equal to a sine omega t minus kx, then what is this? What does this a represent?
Amplitude.
Amplitude. So whatever terms are before this angle, sine theta, we call it as amplitude. So in this case, see, before sine omega t, what all terms are included? 2a cos kx. So this becomes the amplitude of the stationary wave. That is 2a cos kx. Now see, as I've told you, nodes are points of zero amplitude. So it means when we have to calculate nodes, for nodes, we have to substitute r equals to 0 because nodes are points where the amplitude is minimum, 0. So see, if I substitute r equals to 0, this whole term 2a cos kx becomes 0. So cos kx also becomes 0. It means kx is equal to, when do we have cos theta is 0? When we have it as 90 degree, cos 90 degree. So it will start from pi by 2. Then we'll be having 0 when? For what value of cos? 3 pi by 2. Then 5 by pi by 2. So in order to summarize it and make it generalized, you can write it as 2n minus 1 pi by 2. This is for the case of nodes. Now see, kx is equal to what? In general terms, it is equal to 2n minus 1 pi by 2. Now, from here, if you remember, we have seen a relation between k and the wavelength, that is lambda. So k is 2 pi divided by lambda. So if I substitute this value over here, pi will get cancelled and the general equation for x will be 2n minus 1 lambda by 4. Is this clear?
Yes, ma'am.
All right. So for case of nodes, it will be lambda by 4, 3 lambda by 4, 5 lambda by 4, and it will go on. So the positions of 0 amplitude are the nodes, and the amplitude will vary with this. And the amplitude will be 0 for nodes. So this implies that it is odd multiple. You can even see it from here. For values like this, n equal to 1, 3, then 5, for such kinds of values, the nodes come at these positions. Then we have the antinode. So before proceeding towards the antinodes, let's see the position of nodes. If I say what is the position of the first node, then what do we have to do? We just have to simply substitute the value of n equals to 1. See, when we are substituting n equals to 1, n as equal to 1, then x is equal to, in this equation, 2n minus 1 lambda by 4. So the first node we will be getting at which place? Lambda by 4. Then the second node at which place? 3 lambda by 4. So this will go on. X will be having values like lambda by 4, 3 lambda by 4, 5 lambda by 4, and so on. These will be the position of the various nodes. Then we have the antinodes. As I've told you, antinodes are the points of the maximum displacement. So see, it means 2a cos, this was the equation for amplitude, 2a cos kx. All right. So if this is maximum, it means this whole term is maximum. So 2a cos kx is maximum at what? The maximum values for cos can be plus 1. So this will begin with 0, then pi, then 2 pi, 3 pi, 4 pi, and n pi, 5 pi, 6 pi, and so on. So this will start from 0, then 1, then 2, then 3. So antinodes are those positions for which the amplitude, that is 2a cos kx, this has its maximum value, that is plus minus 1. This implies that it comes as an integral multiple of pi, that is pi, 2 pi, 3 pi, 4 pi, starting from 0. And you can even see that adjacent nodes for the value of calculation of adjacent nodes, these are separated by lambda by 2. Because see, if you put n equals to 1, this will be lambda by 2. At n equals to 0, x will be equal to 0. At x equals to 1, at n equals to 1, x will be equal to lambda by 2. Then again lambda, then 3 lambda by 2, and so on. So it means the adjacent antinodes are separated by lambda by 2, and the distance between a node and an adjacent antinode will be lambda by 4. Is this clear? Nodes and antinodes.
Yes, ma'am.
Okay. Note down these, write down these, then we'll do some questions based on this. Hishma, is it clear to you?
Yes, ma'am.
Ma'am, can you scroll down?
Ma'am, can you scroll down?
Done, ma'am.
Okay, let's do question ratings. See, it says y is equal to 6 sine 2 pi x divided by 6 cos 160 pi t. We have to, okay, second wave is not given. This is for the first wave, and for the second wave, it should also be, let's say, 2. Okay, let's use this way only. See, what is the standard equation that we have seen for a stationary wave? It was 2a sine kx cos omega t. Right? This is what we have seen. So see, we have to find out the frequency, amplitude, and wavelength of this only. So we don't require any other wave. This is sufficient. So we have to first find the frequency, amplitude, wavelength of this original progressive wave, and then we have to derive the equation for this. So see, for the calculation of frequency, if you see it clearly, 2a is 6, then sine we have, then x is this, so this all term will be k, 2 pi 6. You have to compare it to the standard equation. If this is your standard equation and this is the equation given to you, then you have to compare both of these. So 2 pi by 6 will be k, then cos omega t. Omega will be what? 160 pi. So if you look at carefully, this is just an analog of this equation. So for the calculation of frequency, we don't have frequency directly given over here, but we have omega. Chase, what is the value of omega?
Cos omega.
Cos omega. Yes, what is the value of this omega? This is the equation provided to you.
165.
165. Omega will be 165. So see, omega is equal to 2 pi nu. Nu is this frequency. This is the relation between angular frequency and the linear frequency. So if we put it, 2 pi nu will be equal to 160 pi. Pi and pi will get cancelled, and then frequency will be 80 hertz. Is this clear?
Yes.
Yes,
ma'am.
ma'am.
Okay. So you only tell me what should be the amplitude. This is the frequency.
3.
3, exactly, because 2a is equal to 6. So a will be equal to what? It will be 6 divided by 2. This will be simply 3. Let's say this hole is given in centimeters. This will be 3 centimeters. Then we have to find out the wavelength. See, we don't have lambda directly given, but we have the value of k, and we have a relationship between k and lambda. So what is the value of k given to you?
2 pi by
2 pi
6.
by 6.
Yes, correct. 2 pi by 6. So see, 2 pi by 6 is k. Also, k is equal to 2 pi by lambda. So if I put it and equate it, 2 pi by 6 will be equal to what? 2 pi by lambda. So from here directly we can say lambda will be equal to 6 centimeters. And amplitude is what? 3 centimeters. So see, we have all the values with us. Now, our equation of original progressive wave, the standard wave that we have seen, that is y equals to, for this is for the second part, y is equal to a sine omega t minus kx. So see, we have the value of amplitude with us now, we have the value of omega with us, and we have the value of k with us now. So we can directly establish an equation for this. So a was 3, this will be sine, omega was what?
160 pi.
160, yeah, 165. omega was 160 pi t minus k. K is 2 pi. This is the equation of the original progressive wave. Fine? Is this question clear?
Yes,
Yes,
ma'am.
ma'am.
Okay, first note it down, then we'll do more questions. Yes.
Done, ma'am.
Oh, let's see one more question. See, this says stationary wave set up by superposition of two waves. This is given by y1 is equal to this equation and y2 is equal to this equation. we have to find displacement of particles situated at x equals to 1 meter. This means amplitude at x, we have to calculate the amplitude at x equals to 1 meter. So when it says we have to find the displacement of the particle, we are actually calculating the amplitude. Now see, if you notice, this is similar to what we have derived. What's the difference in these two equations? Just there's a difference of this plus minus sign over here and a positive plus sign over here. This indicates what? The two different directions of these two waves, which are superposition or superimposing on each other. So now see, we have in the beginning of the class only derived a value of amplitude for these equations. See, aren't they in these two forms, incident wave and reflected wave, a sine omega t minus kx and a sine omega t plus kx? Yes or no?
Yes.
So see, we have derived already the amplitude of the standing wave. What is it? 2a cos kx. So if you compare it to the question that is given, even if you derive it further, if you add these two equations, ultimately you will be left with what? 2a cos kx sine omega t. And see, from here, this much is the amplitude. So amplitude's equation is what? R is equal to 2a cos k of x. Now see, we have to find the amplitude. We have to find this value at x equals to 1 meter. So see, for the resultant amplitude, 2 is constant. Look at these two equations and tell me what is the value of a.
0.0.
0.05.
Yes, both of you are right. It will be 0.05. Fine. This is cos. Now see, look at this equation again. Now tell me what is the value of this k?
1.
1. Because it's given minus x. It means minus what we have. We have it as minus k of x. Means k is equal to 1. All right. So we have k is equal to 1 x. X is already given in the question, that is 1. 1 into 1. So what do we have now? 2 into 0.05 will be 0.1 and this will be cos 1. Easy? Clear to you?
Yes,
Yes,
ma'am.
ma'am.
Okay. We'll do one more question, but before that, you just write it down.
Ma'am, can you scroll? Done, ma'am.
Okay, see, we have one more question. It says to make a standing wave which has a node at x equals to 0, one equation is this. The first wave is this. See, two waves are there which superimpose and construct a stationary and standing wave. So one of the waves is this, and you have to identify among these which should be the other wave. So the hint that is given that at x equals to 0 means we have to get a node at x equals to 0. So just try this question once and let me know which option is matching. Just in case if you will be needing few trigonometric equations, I'm writing it down. Just in case if you need, note this also as well along with the question. Sine C plus sine D is equal to 2 sine C plus D by 2 cos C minus D by 2. Sine C minus sine D, this is equal to sine C minus D by 2 cos C plus D by 2. Then cos C plus cos D, this is 2 cos C plus D by 2 cos C minus D by 2, and one more. If it says cos C minus cos D, this will be 2 sine C plus D by 2 sine C minus D by 2. Have you written the question?
Yes,
No,
ma'am.
Okay, first note it down. Yes, written the question.
Yes, ma'am.
Okay. Now see, it says that we have to find a wave that is having a node at x equals to 0. Firstly, before even beginning the question, you can eliminate two options directly. See, the first wave is y is equal to a cos omega t plus kx. So the other wave should be in opposite direction. These two waves travel in opposite direction, then only they make a standing wave, no? So out of these, can you think two options that can be eliminated directly without even solving? Yes,
The fourth one.
the which one?
Fourth one.
Fourth one. This one. The fourth one.
Yes, ma'am.
Yes, see, not only the fourth, but even the third one, because it is not having a minus sign. This is y equals to a cos omega t plus kx. So obviously, had it been minus a cos omega t plus kx, then we would have eliminated these minus signs. So fourth one will definitely will get eliminated, as well as the third one will also get eliminated, because it is not having minus sign. Because then these two waves and these two waves, these are traveling in same direction, but we want a wave that is traveling in opposite direction. Now see, we are left with two options, minus a cos kx minus omega t, then minus a sin kx minus omega t. Now see, node at x equals to 0. What do we have at x equals to 0 firstly? If you remember, at x equals to 0, over here, at x equals to 0, what do we get? Do we get a node or antinode?
Antinode.
Antinode. So this is a function of what? Cos. So it means if the question is asking us node at x equals to 0, it means it will be the opposite of it, reverse of it. That is, we will be having sign in our equation. We want the final resultant equation will be consisting of sign. So see, in order to obtain sign, the two waves should have cos or sine. You can easily identify it from the equation that I have written. See, combination of sine will give sine as well as cos. Combination of two sines again will give combination of sine and cos. See, combination of two cos will give cos in this case. The only equation possible that can get a sine is two combination of cos theta only. So if you look in these two options, see, these will definitely get eliminated because the signs are same. That is, it travels in the same direction. If you look in these options, if I take cos and sine and add them, then combination of cos and sine, we have to get sine in our final equation. So we have to consider two combinations of cos. So simply by directly looking at it, even we'll get the answer as this. Even if you try, if you prove it, If this is the equation, if we superimpose both the equations, one equation was a cos omega t plus kx. Now I'm adding the equation that I've chosen, the first answer, minus a cos kx minus omega t. When I'm adding up, see, y will be equal to 2a sine kx will be there, and then cos omega t will also be there. So see, sine kx is equal to 0 over here. Sine kx will be equal to 0. So kx will also be equal to 0 and x will also be equal to 0. And that is what we require. Is it clear? Why is the answer first one only?
Yes, ma'am.
Yes, ma'am.
Okay, so just note down this. Done?
Yes.
Okay. Now see, this was standing wave for a general case. If we specifically talk about standing wave in a string, see, when we do discuss it over here. See, standing wave in case of string, if you see the incident equation for this one will be, if I say the standing wave is fixed at both the ends. Like let's consider a string. The length of the string is L. If I say the length of the string is L and this is stretched between two fixed support points, like this. This is one supported point and this is another supported point. So when a wave is set up in the string, when we pluck it, if you pluck it over here like this at some point, the wave will travel in both the directions and it will be reflected at each end. First, it will be reflected over this end, then it will get reflected over this end. So see, if we have to derive the equation, see for the incident wave that we have. For the incident wave, A will be equal to what? A sine omega t minus kx. And for reflected wave, it will be the same with the negative sign and the different direction for it. Now see, if when we are implying the superposition principle, superposition will be what? It will be sum of for the incident wave and the displacement for the reflected wave as well. Now see, if we add both of these, a sine omega t minus kx and this minus a sine omega t plus kx, if we add both these two equations, see, finally we'll be having minus a sine omega t plus kx and plus a sine omega t minus kx. If I take amplitude common from both of these, then what will be left? Sine omega t plus kx minus sine omega t minus kx. So if I write the standard value of this equation, the standard equation will be what? It will be minus 2a kx cos omega t. Similar to the equation of the standing wave that we have. Now see, regarding the amplitude here, it will be consisting of sine kx. Just in case if you don't know this identity, sine a plus b is sine a plus b minus sine a minus b. This is 2 cos a sine b. This is the identity which is 2. So see, from this equation we have amplitude of the standing wave as 2a sine. Now see, we use boundary equation, that is x equals to 1, y will be equal to 0, and x equals to 0, y will be equal to 0. This means this is at x equals to 0, and this is at x equals to L, because the length of the string is what? The length of the string is capital L. Now see, if I write minus 2a sine kl cos omega t, x is what? I can replace x with L. And for the first one, y is equal to 0. So sine kl will also be equal to 0, and similar to the previous cases that we have seen. When kl or kx was equal to 0, what were the cases? N pi, 0, pi, 2 pi, 3 pi, 4 pi, and so on. So kl will be equal to n lambda, which we were using as L. X, now we are using it as L, because L is the total length of. So again, on using this equation, k is equal to 2 pi divided by lambda. If we put it over here, pi will get cancelled, lambda's value will be 2L divided by n. So for the first one, if I say first mode of vibration, I'll have to keep the value of n as 1. So what will be lambda?
Well,
Lambda will be 2L. And if I take it for the second mode of vibration, then lambda will be equal to L, because 2 will get cancelled. So see, in general, if we have to write the frequency of nth mode of vibration, this was the wavelength. For the frequency, it is lambda frequency for the nth one divided by 2L. This is the frequency. So for frequency, we use this relation. Velocity is equal to frequency multiplied by lambda, wavelength, and this frequency is equal to velocity divided by wavelength. So frequency will be simply wavelength divided by 2L. So whatever values of wavelength you are getting, you can substitute it for this one. This is the wavelength at nth one. For first one, it will be for at n equals to 1. Frequency of first one will be what? Lambda 1 divided by 2L. And what is lambda 1? Lambda 1 is 2L. So frequency 1 will be 2L divided by this 2L, that is 1. Then for the second one, you can put n equals to 1, and then you can substitute in this. Is this clear?
yes, ma'am.
Yes,
Okay.
ma'am.
Noted till here first.
Ma'am, can you scroll down?
Noted?
Yes, ma'am.
Okay. Now see the formula for the speed in a string, in a transverse wave. This is given by V is equal to. This is the speed of transverse wave in a string. Speed of transverse wave in a string. So V is equal to under root T by M. T is basically the tension. And M is not only mass. This is mass per unit length. This is if I say 5 kgs is for, let's say, meters. So this will be 5 by 6, that is mass divided by length, mass per unit length. And the frequency, then it will corresponding to this, it will be n by 2 lambda under root t divided by n. This is the standard value for velocity and the standard value of frequency. Now see the first mode of vibration that we have for the first harmonic wave, which we say. See, when we put n equals to 1, see what all we get. For n equal to 1, lambda n, that is the general formula, 2l by n, this will be equal to 2l. And length will be equal to half of the wavelength. Then we have frequency, nv divided by 2l. See, this is that one only. Here just I have written in terms of velocity, otherwise it was n divided by 2l and root t by m. Fine, so frequency n is nv divided by 2l. So if I put n equal to 1, this will be simply v by 2l. Now see this frequency, this new one that I am getting, this first frequency, this is called the fundamental frequency. This frequency is known as the fundamental frequency, or you can say the first harmonic fundamental mode, or the fundamental frequency. So it is the minimum frequency that can set up the standing wave. Then at n equals to 2, this will be the second harmonic, second mode of vibration. So second mode of vibration occurs for n equals to 2. At n equals to 2, the corresponding wavelength will be equal to lambda as discussed previously. And the frequency for the second one, this will be equal to 2v divided by, see what was frequency? Frequency was nv divided by 2l. If I put n equals to 2, this will be 2v divided by 2l. So 2 will get cancelled, v divided by l will be left. So second frequency will be equal to what? 2 times the first frequency, twice the fundamental frequency that is given. New one was what? New one is the fundamental frequency. The second harmonic that we are getting, second harmonic one is basically twice the fundamental frequency. See this frequency that we are getting, the second harmonic that we are getting, this is also called, apart from harmonic, second harmonic, this is called the first overtone. This is known as the first overtone. So second harmonic, for the second harmonic, if we are having first overtone, then for the third harmonic, which overtone should be there? Yes. If for second harmonic, we are having the first overtone, then for the next one, next higher one at n equals to 3, that is the third harmonic, which overtone should we have?
Second.
Second one. Then for the fourth harmonic, which overtone we'll be having?
Third.
Third one. Okay, because it starts from this second harmonic, we are getting the first overtone, and its value is twice the fundamental frequency. Then if we put it for third harmonic, this will be lambda 3 will be 2l by 3, frequency 3 will be 3 times the first. And also one more thing, if we have to find out the position of nodes, then we can use it through n plus 1. How many nodes will be there? Like if I tell you, if only one wave is there. See, antinode will be 1 only. So that's why we are saying n. If I say n equals to 1, look at this example. Antinode will be 1 only. So that's why I have written antinode is n. If I talk about the node, see, one node will be over this end and one node will be over this end. So if n was equal to 1, this antinode was equal to 1, but the nodes were coming 2. It means if n is there, nodes will be n plus 1. All these are clear?
Yes.
Note down till here, then we'll do questions on this.
Can you scroll down?
Noted till here?
Yes, ma'am.
All right, then let's see a question on this. See, it says a stretched wire emits a fundamental node of 256 Hertz. So keeping the stretching force constant, the reducing the length of wire by 10 centimeters, frequency becomes 320 Hertz. That is, from 256 Hertz, it becomes 320 Hertz. And we have to find out the original length of the wire. See, we have seen a relation of frequency that was n divided by 2L under root T by M. T is tension, M is mass per unit length. Now see what it says. When the frequency was 256 Hertz, when the frequency was 256 Hertz, it was initially. See, this is, if it is, it says it is for the fundamental node of frequency. So if it says fundamental node is 256 Hertz, can any one of you guess the value of N? Yes, look up into your notes. You must have written it right now only. Fundamental node of frequency is which one? Fundamental mode of vibration. Which harmonic motion? Yes, Afifa, Hishma.
Harmonic.
The first one. See, this is the first harmonic one, that is n equal to 1. This is the fundamental frequency. If it says first overtone, then it will be the second one. But if it's saying the fundamental frequency, this is the first one, that is n equals to 1. All right, so if it says randomly, like fifth overtone, if it is saying randomly fifth overtone, then it means n equals to 6. But if it's specifying fundamental, this means n is equal to 1. So this means frequency first one will be 1 by 2L under root T by M. Now what does it say? It says that the stretching force is remaining constant. Means what is the force over here? The tension. So it means the tension is not changing. This is constant. Then it says the length of the wire gets reduced by 10 centimeters. Then only the frequency becomes 320 hertz. So it means if the frequency, this is 256. This is 256 is 1 by 2L under root T by M. If it is 320, it will be 1 by 2. What should be the value of L? Should I write it as L only for the 320 case? Look, this is the question. For the 320 hertz case. Is the length remaining the same?
No.
It is getting reduced by 10 centimeters. So it will be L minus 10. Then these terms are constant as specified by the question. Now see, what do you have to calculate? You just have to find the value of this L. The question asks us to calculate the original value of length of wire. So we don't have to find tension. We don't require this mark. What all do we require is the calculation of this length. So see, we have these two equations. We can take the ratio of them. 320 divided by 256. This will be this whole term, that is 2L minus 10 by T by M. Then for this 256 term, this whole term, then that is, it will get reciprocated. We'll write the reciprocal of it. This will be M by T. So this gets cancelled. 2 gets cancelled. So what do we have? We have L by L minus 10. This is equal to 320 divided by 256. Now see, if we can even cancel these, divide these two. This will be 5. This will be 4. 16 into 4, 16 into 5. So see, if I cross multiply, this will be 4L equals to 5L minus 50. So 50 will go in this side. This will be 5L minus 4L. So L will be what? 50 centimeters. Understood?
Yes, ma'am.
Any doubts from this portion? This topic, speed of wave?
No, ma'am.
Okay, just note down the solution of it. And this question. From here you have to write.
Ma'am, can you score? Done.
Okay, see, these are very too easy direct questions. First one says when the length of vibrating segment of sonometer wire is increased by 1%, we have to find the percentage change in the frequency. Length of the sonometer wire. See, this sonometer wire, let me discuss it first. See, sonometer is basically a device that consists of a box like this. Over here is the pulley, and one end is fixed on this pulley from a rigid end, and the other free end. This free end is connected to a mass. Let's say this block has a value m. M is the mass. So tension will be acting over here, and mg will be acting over in this downward direction. So the frequency of this sonometer, this is given by 1/2 L under root T divided by M. So this is what sonometer is. The rest of the things remain the same. So see what in this question it is asking. It says effect of length, effect on frequency when length is increased. Regarding with sonometer wire. So what is the frequency? Frequency is basically 1/2 L divided by under root T by M. Now see, if the length is increased, if the length of the wire vibrating segment is increased by 1%, if this length is increased by 1%, then we have to calculate what is the frequency change, percentage change in the frequency. So when the length of vibrating segment of sonometer wire is increased by 1%, what should be the percentage change in the frequency? So just try this. What should be the answer of it? You don't even have to calculate much in this. See, you don't even have to calculate this. It says if the length is increased by 1%, if the length gets increased by 1% and frequency and length are inversely proportional to each other. Frequency is inversely proportional to the length. So if the length increases by 1%, then the frequency will decrease by 1%. So the correct option will be option C. Then we have a graphical question which says we have to find the correct graph between frequency and the square of density of the wire if its length, radius, and tension is kept constant. So what is the relation that we have regarding the frequency? It is 1/2 L under root T by M. Now see, do we have density in this relation?
No.
So it means we have to find out the relationship between the frequency n, if frequency is taken as n over this side, and we have to take it as the square of density. So any relation between mass and density?
Mass by volume is density.
Density is equal to mass by volume. So see, this mass that we are considering in this equation, this is not only mass, this is mass per unit length, as I've told you. This is tension, this is mass per unit length. If it's mass per unit length means m divided by L. And if I multiply area on both the sides, that is the numerator as well as in the denominator side. Now see, length multiplied by the area. Length multiplied by the area gives us the volume. So this will be MA divided by V. And what is mass divided by volume?
Density.
This is density. This will be rho A. So we have a relation between mass per unit length and density now. So mass per unit length is equal to the product of the density and the area. So if I substitute this in the equation that we have for the frequency, that is 1 by 2L under root T by M. Now instead of M, I should write rho A. So see, frequency is given by N. So N is equal to 1 by 2L under root T by rho A. So what is the relationship between N and root rho, under root of rho? How are they related?
Inversely proportional.
Inversely proportional. So frequency is inversely proportional to the root of the density. So look at these graphs, A, B, C, D. If frequency and the root of density are inversely proportional to each other, which is the correct one?
C.
C, because it is inversely proportional. All right, note down these two questions as well.
Ma'am, can you scroll down? Ma'am, can you scroll down? Done, ma'am.
Okay, note down that also. Sonometer also. One more thing. See, from this, you can easily say that there's a law of mass says that the frequency is inversely proportional to the square root of mass. Then we have law of length. Law of length says that frequency is inversely proportional to the length. And the final law that we have is law of tension, which says that the frequency is directly proportional to root of tension. Just note down this also. And just so that this wire does not slack, two wedges are kept.
Done, ma'am.
Both of you?
Yes, ma'am.
Now see, what we are left with is open organ pipe. Open organ pipe means the pipe that is open from both the ends. So if a wave travels in this direction, or if the wave can travel in this direction, from here we'll take x equals to 0 and y will be having its maximum. See, this is an open boundary. This is an open boundary. And if I say the length of the wire, the length of this pipe is L, so x will be equal to capital N in this. And here also y will be having its maximum value. So see, for the incident wave, incident that is coming, y will be equal to a sine omega t minus kx. And for the reflected one, let's say this is the incident one, this is the reflected one. This will be a sine omega t plus kx, just the difference of direction. Now see, for the standing wave, we have to use superposition principle. So see, using superposition principle, y incident, y reflection, the sum of these two will give the resulting standing wave. So again, similar to the previous one, the way we have it, this will be, y will come out to be 2a cos kx sine omega t. And the wavelength will also be 2L divided by n. So for n equals to 1, wavelength will be 2L, that is length will be half of the wavelength. Similar to the previous one that we have done. One more thing, frequency of nth mode, this will also be the same. Speed of sound waves is velocity. So frequency for nth mode of vibration, this will be nv divided by 2L. Then see, we have one more term, Laplace correction. See, Laplace pointed out that Newton was wrong in assuming that pressure variation during the passage of sound. So Laplace pointed out few corrections and resulted in this equation, v is equal to under root gamma p by rho. So if you remember gamma, this was the ratio of two quantities. We have done this in adiabatic process as well.
CP by CV.
Yes, right, correct. This is Cp by Cv. So this is that one only, Cp divided by Cv. This is the ratio of specific heat at constant pressure to the specific heat at constant volume. Why? Because Laplace pointed that propagation of sound wave takes place under adiabatic conditions. That's why this correction was done. And see, so that's why the frequency, the velocity that we'll be having. What was the initial velocity, initial frequency that we took? That was under root 2 by m for a string. Here in this case, it will be gamma p by rho because this is the value of the velocity. This is just the change that has occurred in case of open organ pipe. So see, for the first harmonic node that we have, lambda n will be equal to what? 2L divided by n. This is lambda n. So at first harmonic, and this is also known as which mode? First harmonic is known as which mode? Fundamental. Fundamental mode. So at n equals to 1, lambda will be 2L and length will be half of the wave. So see, for the first harmonic mode, since this is open at both the ends, this will be the first wave. This will be the second wave. So see, these 2 points are giving us the antinodes, and this point will give us the node for this wave. Oh, fine. So see, for first frequency, this is the fundamental frequency. This is the fundamental frequency, that is 1 by 2L multiplied by under root gamma p by rho. Then we have n equals to 2. This is for the second harmonic. So again, second harmonic will give the first overtone. Yes or no?
Yes.
So lambda 2 will be what? This will be the length. This is just similar to the previous one. The change that has occurred is over this side. That gamma p by rho has been added up. So the frequency will be twice of the fundamental frequency. So see, for n equals to 2, this was for the n, for n equals to 1. This was for n equals to 2. So see, these are the antinodes. This will be the node. Then again, this, since it is n equals to 2, we have one more over here. So in total, it will be like this. So antinodes will be here, and the nodes will be over these. These will be the nodes, and these will be the antinodes. Clear?
Yes, ma'am.
No, not till this one.
Can you scroll down? Can you scroll? Done, ma'am.
Done, ma'am.
Okay, fine. Then if you have any doubts, you can ask me right now as well as tomorrow. So I'm stopping here today. We'll continue in tomorrow's class. So tomorrow's class will be at the usual timing that we have.